then we're going to look at the negative zeros. What time is it? I've got time. Negative zeros. And this time we're going to use f of negative x. Let's take the same function, evaluate in terms of negative x. So f of negative x to the third plus negative x plus 10. So we evaluate that, we get, since that's an odd exponent, we're going to keep the negative, and that's a negative, and that's a positive. Now we have one sign change, where it goes from negative to positive. Okay, so that means we have one possible negative zero. So here's what he did on his. He went back, and since we didn't have any positive zeros, he went back, and when we look at this list here, he only took the positives. So he originally wrote out negative 1, 1, negative 2, 2. He does it the other way around. He goes 1, negative 1, 2, negative 2, 5, negative 5, 10, negative 10, right? So he crossed off all the positives. So we're just left with the negatives. So we have, out of all the possible answers we came up with in this step, we can only have positives, right? And out of all the, we can only have negatives. And out of all the negatives, we can only have one possible negative zero that are actually rational, right? The other ones could be like irrational. So that's done. So now 5D, we're going to find all the real zeros. Find all real zeros. And to do that, we want to factor, if possible, right? So we're going to take this f of x equals x to the third original function plus x plus 1, right? But you notice, like, we have an x to the third, we have no x to the second, we have an x, and then we have a 1. We need to represent that when we go to do synthetic division, so we're going to do x to the third plus 0x to the second plus x plus 1. That way we have a placeholder for each one. So normally I would start with 1, but since we don't have any positives in ours, we're going to start with negative 1. So 1, 0, 1, and this was actually a 10. Okay, so bring down the 1. 1 times negative 1 is negative 1. 0 minus 1, negative 1. Negative 1 times negative 1, positive 1. 2 times negative 1, negative 2. We have a remainder, so x equals negative 1 is not a root. So now that we know that, we can move on. So we've done negative 1. We've done negative 1. Didn't do positive 1 because positives aren't a thing. So that we can't do 2 because, again, positives aren't a thing. But we can do negative 2, right? So we can do negative 2, and remember our numbers here for it were 1, 0, 1, 10. 1, 0, 1, 10. Right? So bring down our 1. 1 times negative 2 is negative 2. And then 0 and negative 2 is negative 2. Negative 2 and negative 2 is positive 4. 1 and 4 is 5. 5 and negative 2 is negative 10. 10 minus 10, 0. This is a root. So we're going to take this one, x plus 2. Because remember, if x equals negative 2, x plus 2 is equals 0. It's like the opposite thing. It's sort of like when you solve backwards, right? Because if you went negative equal to 0 minus 2, x equals negative 2, right? So, and then we're going to take this whole thing and we're going to bring it down in here. So that would be, what? X squared minus 2x plus 5. Okay, let's see, does that factor something that multiplies to 5 but adds to negative 2? Let's see, 5 and 1. I don't think that factors. We have to... Okay, so since this doesn't factor, he's going to use the quadratic equation, minus b plus or minus square root of b squared minus 4ac all over 2a, and then he had opposite of negative 2 plus or minus square root of negative 2 squared minus 4ac over 2 times, what was our a? 1, which gives you 2 plus or minus, if you stick that in the calculator, apparently it is negative 16. And this makes sense, because remember we can only have one negative 0, and we came out with that x equals negative 2, so we can't have anything else per our solving, right? Except we can't have anything else that's rational. We can't have anything else that's rational. So this is like an imaginary number, so we're good. Negative 16 over 2. And then if we reduce this down, right, this would be 2 plus or minus, that's 4. Square root of 16 is, or 16 squared is 4. Negative 1 squared is I over 2. I can take 2 out of this one and 2 out of that one. 2 divided by 2 is 1, plus or minus 4i divided by 2 is 2i. That's our zeros. So remember we had this x equals 2 from when we did our synthetic division, right? So our zeros are x equals that negative 2 from the synthetic division, and x equals 1 plus or minus 2i. Okay, so to graph it, where are my side notes? So to graph it, I like to look at, for our thing here, we can see that this had a multiplicity of 1, right? I make a note, multiplicity of 1. This is not going to even be graphable because it's imaginary, so just this is the only one that's what we're going to worry about. The other thing is that if we look back at, if we want to look at end behavior, remember end behavior? It matters if it's, two things matter. Is it positive or negative? So let's go back and look. No negative sign, right? Coming from here, it's positive. And then, what is the degree of this one? So that's the one where we look at the multiplicity of the factors. Okay, so this one doesn't factor out to anything real. This one does, and it factors out to one thing in here, right? So we only have one factor that we're worried about, right? Because if we look at our zeros, this one has a multiplicity of 1. This one can't even be graphed. So we're going to add the degree, what is it called? We're going to add the multiplicity stuff, right? We've only got 1. That means it's odd, right? 1, 3, 5, anything like that. If we would have had, let's say we would have had x equals negative 2, or, you know, like if we would have, let's say this factored, and it would have been like, it factored into like x plus 1, x minus 3, and whatever, x plus 5, right? Let's say it was 3 things. Multiplicity of 1, multiplicity of 1, multiplicity of 1, right? So that it'd still be odd because it'd have a degree of 3, right? This one just happens to have something really messed up looking. So it's odd, right? So now that we know that it's odd, we can predict the end behavior. We know that this side's going to be going up and this side's going to be going down, right? So as x approaches infinity, y approaches infinity. As x approaches negative infinity, y still approaches y approaches negative infinity, right? Okay, so now we can graph. So thing with our graph here for 6e is that we don't have a lot of points. We only came up with one rational root, right? And that occurred, remember, from our zeros here. We just had that x equals negative 2. So we'll go back, x equals negative 2. The other thing that we can graph is the, what is it called? The y-intercept. So f of 0, well, remember our f of x is x to the third plus x plus 10. So f of 0 equals 0 to the third plus 0 plus 10. F of 0 equals 10. So the y-intercept is over 0 up 10. So, okay, we know that because we just have the 1, 0, and with a multiplicity of 1, giving us an odd number, right? And it's going to be positive this way, or going up this way and going back that way. You know that this is going to end up this way somewhere, and this is going to end up that way somewhere, right? The other thing I know is that up somewhere up here, like, there's going to be a y-intercept. So if it's going up this way, somewhere this way, we're going to go that way. Somewhere this way, we're going to go that way. That's like really as far as you can know there. And then like he's got the shape of it like funky looking. And then he's got this going out like that. It's a funky looking graph. But you can do that the same way with all the other graphs, and they make more sense. Just the steps that I would say are first plot your roots, and then when you have your roots, show the direction of things. So that's it. That's how we would solve this problem. I love you.